Hello students, welcome to Study Life. In this video, we are going to talk about the preparation of phenols and the further topics of the topic alcohol, phenols and ethers with respect to your board exams. Now in the previous video, we have completed a couple of important topics, and in this video, we are going to complete the other important topics. A quick revision. This will be a quick revision. Important questions. You will come to know which are the important questions, how to present an answer. So let's get started, students. So welcome here for the lecture. So now we'll start with the next topic, that is preparation of phenols. Now in the preparation of phenols, the first method is from chlorobenzene. Now we'll just quickly talk about the methods that we are discussing. Now from chlorobenzene, the name reaction, it is also called as Dow's process. Now in this reaction, there are very important words. The key points that you should have is chlorobenzene will react with, what is the reacting condition? Yes, 623 Kelvin, 150 atmospheric pressure, and that gives you the formation of phenoxide. And this phenoxide, which is obtained in the first step, will undergo acid hydrolysis. So this will undergo acid hydrolysis. Here this is acid hydrolysis and will give you the formation of phenols. So that's your first method of preparation of phenols. Moving on, the next one is from cumene. Now the next method, that is from cumene. Now when I'm talking about cumene as the second method of the preparation, some very important keywords for cumene as well. The first important keyword for cumene, this is also called as isopropyl benzene. So the question can be framed in either of the way, either asking you cumene or asking you isopropyl benzene. So this reaction for isopropyl benzene. Now in the reaction for isopropyl benzene, let's begin this reaction. This is oxidation reaction of isopropyl, and the reacting conditions as mentioned are very important. Cobalt naphthenate and 423 Kelvin. First step will give you the formation of, yes, cumene hydroperoxide. So first step, it is the peroxide formation taking place, and this peroxide will then undergo the further reaction, that is hydrolysis. This is with dilute HCl and gives you the formation of phenols, that is phenol plus acetone. So this was your second method. A quick recap, it is from cumene. Now cumene is called as isopropyl benzene. One more important thing that I need to just handle out here is this word. What is that word? Commercial method. So you can get a question like commercial method of preparation of phenols. So there also the answer remains the same. Commercial method of preparation of phenols, it is again from cumene. So this was your second method. Moving on quickly to the third method. Now in the third method, what we have? The third method of reaction, that is from benzene sulfonic acid. When I'm using the word benzene sulfonic acid, what is that sulfonic group? It is SO3H attached to the benzene ring. Reacting conditions again, NaOH and 573 Kelvin. Once you are writing this in your board examinations, for top cases, for marks above 65 out of 70, again when your papers are being checked, reassessed, these are the key points where it is considered. So make sure that you're writing these values very carefully. Now this is benzene sulfonic acid will react with NaOH, that is reacting with the base, and that gives you, yes, the first compound is sodium benzene sulfonate. Now this sodium benzene sulfonate will then again undergo further reaction with fused NaOH. Now see the word, I have used the word fused NaOH. That means the temperature is greater. Yes, the temperature is how much? The temperature is 523 Kelvin. And this sodium benzene sulfonate, when will it react? When it is reacting with fused NaOH, what does it gives you? Yes, it gives you sodium phenoxide. This sodium phenoxide further reacts with dilute HCl, acid hydrolysis, reacting with dilute HCl, and that gives you the formation of phenols. So this was your third method, that is from benzene sulfonic acid. Sulfonic acid, the group is SO3H, and that reacts with NaOH to give you sodium benzene sulfonate. What type of reaction? Neutralization. See these words again coming up that you should understand when you're writing your exams. So that is neutralization reaction. That neutralization reaction, again it will react in the next step with NaOH under fused condition. And what does that gives you? Sodium phenoxide, and that sodium phenoxide in the next step again undergoes acid hydrolysis. So when it undergoes acid hydrolysis, that will result into the formation of phenols. So this was your third method of preparation. The next reaction is from aniline. Now this is the fourth method of preparation of phenols, that is from aniline. Now what is aniline? Yes, benzene ring attached to NH2, that is called as aniline. Now this reaction with aniline reacts with what? Aniline reacts with nitrous acid. So here aniline is reacting with nitrous acid. Now there is a confusion, nitrous, nitric. So be very clear with the students. Nitrous acid is HNO2. Nitrous acid is HNO2. Nitric acid is HNO3. So that confusion should be cleared out. Second important thing, nitrous acid is not available in the nature. You are synthesizing it. How do you synthesize it? That's also something very interesting and very important. Here it is. That is NaNO2 reacting with HCl. So here when NaNO2 reacts with HCl, that NaNO2 on reacting with HCl gives you nitrous acid. Now this nitrous acid on reaction with aniline, yes, what it gives you is diazonium salt. So this will give you here the formation of N2 plus Cl minus, a very important compound. Benzene ring with N2 plus Cl minus, that is called as benzene diazonium chloride. Now this benzene diazonium chloride, in the next important step, it will undergo hydrolysis. Yes, again when it is undergoing hydrolysis, it will give you the formation of phenols and along with nitrogen gas. So here this is how you get your next reaction, the fourth one. So this completes all the four methods of preparation of phenols. Now we come to the next important thing, that is physical properties of alcohols and phenols. Now this will be a very general question coming up in the board examinations. Give 4 physical properties, or any specific physical properties will be given, or you can be asked with respect to hydrogen bonding. So there are some keywords that you should remember when you are answering such questions. So let's begin. The first one, nature of intermolecular forces. So between two molecules, nature of intermolecular forces. Now what will that result into? Yes, a very important word, hydrogen bonding. So because of that intermolecular forces, it results into hydrogen bonding. So let's see the structure, how that hydrogen bonding takes place. This is ROH. This is another ROH. Now this oxygen being electronegative, yes, it will have a bond with next hydrogen of the neighboring alcohol molecule. Two different alcohol molecules and it is having a bond. That is what is called as, yes, that is called as intermolecular hydrogen bonding. So this is what is the intermolecular hydrogen bonding in case of alcohols. Same way we have the story for phenols. Here you can see benzene ring with OH, benzene ring with another OH. Now here this is O of the first first phenol, and this is the H of the another phenol, and there is a small dotted line in between that. So this is one phenol molecule, this is another phenol molecule. Between them you have that dotted line coming up, which talks about, yes, hydrogen bonding. So this is the first important point that we have discussed, that is nature of intermolecular forces, which results into formation of a hydrogen bond. That's your first important concept. Now the next one is the physical states. Now this again is something very general that you have. Lower members, then the members of the higher families, higher homologs, that is how you segregate the points. So just keywords to remember. Lower alcohols, how are they? Yes, colorless toxic liquids, and they have characteristic alcoholic odor. The next one, pure phenols. Now for coming up to phenols, now in phenols it will be colorless, it has low melting solid, and it has a characteristic carbolic or phenolic odor. Now this reminds me one thing very important, children. This is carbolic. So that carbolic acid is nothing but phenol. Don't get confused with the word carboxylic acid. Carboxylic acid is different, that is COOH, and carbolic acid is phenols. So you can get a separate question, how will you prepare carbolic acid from? That is nothing but preparation of phenols. Moving on, the next important point that comes up is the chemical properties of alcohols and phenols. Now in the chemical properties of alcohols and phenols, the first one is the litmus test. Yes, in litmus test, obviously, as we already know, that alcohols is not going to show any particular specific test. So water soluble alcohols and phenols can be tested with litmus paper. Neither blue nor red litmus changes color. Now when I say none of them are changing color means it is not going to change the color, means it is going to remain neutral. It's neither acidic nor basic. Nevertheless, aqueous solutions of phenols turns blue litmus red. You can compare this with alcohols and phenols. Alcohols have no action on litmus, whichever it is, blue or red, and phenols will turn blue litmus into red in color. That means they are what? They are acidic in nature. So that is the acidic nature of the phenols. Moving on, the next one, litmus, that is the reaction with bases. Now when phenol is reacting with a base, now AROH is nothing but benzene ring with OH, that is phenol, plus NaHCO3, that is sodium bicarbonate, has no reaction. So acid strength of phenol is being very low, and that is what it does not react with NaHCO3. Although it is acidic, but that acidic strength is very low. And how can you justify? Because it does not react with NaHCO3. Alright, the next one coming up. Phenol dissolves in aqueous NaOH by forming water soluble sodium phenoxide, and that on regeneration, how will it regenerate? It is regenerated on acidification with HCl, a very general property. Now let's talk about some of the important chemical properties here. Yes, the first one. Now this is AROH, that is phenols, will react with a base like NaOH, and this will give you O minus and Na plus. So two opposite charges you are getting over here, O minus and Na plus. That again on reaction with HCl will give you back AROH and NaCl. So try to understand, NaOH when it is reacting, it is ArO minus Na plus. That's a simple reaction. And in the next step, again it reacts with HCl. Now when it reacts with HCl, this H is going to combine over here with O minus, and this Cl will combine with Na plus, isn't it? This Cl is going to combine with Na plus, and that is how you get NaCl. And H combining with ArO minus, that gives you AROH. So this is how you get the formation of phenols. Yeah, moving on to the next reaction, that is characteristic tests for phenols. Before that, yeah, now one more reaction wherein we are talking about alcohol reacting with sodium metal. Now what happens when alcohol reacts with, or what is the reaction of sodium metal on alcohol? You can get a question like this. So what is that reaction? Very quickly, twice ROH, that is alcohol, will react with twice Na, sodium metal, and will give you the formation of twice RONA. Now here it involves the breaking of OH bond. This OH bond has to break. You can see this OH bond on the screen, this OH bond here. This OH bond has to break and will give you twice RO minus Na plus. Now the characteristic test for phenols, in that you have got phenols reacting with FeCl3. This will give you a deep color, a dark color. So that dark color that you get, which dark color? Purple, violet, green, that all is again the formation of phenols. That is a reaction for phenols. Next reaction is esterification. Now what happens in esterification? The name has the answer. Esterification is formation of esters. So here in this esterification reaction, it is the reaction between alcohol or phenol with carboxylic acid. The keyword, alcohols or phenols reacts with carboxylic acid, and it will give you the formation of ester, and this reaction is called as esterification reaction. So this is esterification reaction. Now here in this esterification reaction, we can see here it is ROH plus RCOOH. Now this is ROH, that is alcohol, this is carboxylic acid, and this gives you the formation of RCOOR. What is that RCOOR? That is the formation of ester taking place. Same way, now this is a reaction for phenols. Again, phenols react with acid to give you esters. The next reaction coming up is for alcohols with anhydrides. Now when alcohols react with anhydride, that will give you the formation of ester. So alcohols on reaction with anhydrides gives you the formation of ester along with carboxylic acid. So this is what is the basic idea of esterification reaction, And in esterification reaction, as the name suggests, it is the formation of ester which takes place. Coming on to the next reaction, that is oxidation of alcohols. Now in oxidation of alcohols, yes, primary alcohols on oxidation gives aldehydes, secondary alcohols on oxidation gives ketones, and this can be vice versa. That is, ketones on reduction gives on secondary alcohol, and aldehydes on reduction gives primary alcohol. So you should have that interchanging understanding, primary alcohols to aldehydes, secondary alcohols to ketones, and vice versa, as I mentioned. Now comes a very important reagent which you can expect in your exams for PCC. Now what is PCC? Pyridinium chlorochromate. What is the significance? It brings about limited oxidation, or I can use the word partial oxidation. Means if I am starting from primary alcohol, it will undergo partial oxidation to give only aldehydes, not beyond aldehydes. Then what is beyond aldehydes? Yes, carboxylic acid. So it will not give you carboxylic acid, it will terminate the reaction at aldehydes. So when common oxidizing agents are used, generally it will get to carboxylic acid, but that has to stop at aldehyde step. So we are using PCC, and that PCC stands for pyridinium chlorochromate. The next reaction is for the reaction with, yes, this is the reaction I was talking about, that is primary alcohols giving you aldehydes first, and that aldehyde giving you carboxylic acid. Here you need a strong oxidizing agent. Again, two examples that you can remember, KMnO4, HNO3 and potassium dichromate. So these are some of the common examples of potassium permanganate, KMnO4, potassium dichromate, K2Cr2O7 and nitric acid. Moving on, the next reaction is the reaction that is heating with copper metal. Now when you are heating with copper metal, what exactly happens? So in heating with copper metal, it is reaction at 573 Kelvin, which gives you the formation of aldehydes. Primary alcohols giving you aldehydes. Yes, secondary alcohols gives you ketones. Only the arrow conditions are changing. Be very clear. It is copper and 573 Kelvin. The next one, tertiary alcohols on dehydration gives you the formation of alkenes. So this is wherein you get the formation of alkenes. The next reaction that we have is oxidation of phenols. Now we did oxidation of alcohols, oxidation of phenols. What basically is the reaction? In the oxidation of phenols, phenols undergoes oxidation using CrO3 or sodium dichromate and sulfuric acid. Conditions we need to remember. What it gives you is benzoquinone, catalytic hydrogenation of phenol. Yes, phenols on reaction with 3H2. Now whenever you are using the word catalytic on the arrow Ni, Pt or Pd, or even you mention Ranni nickel, it's absolutely fine. But then catalytic means what exactly? That is Ni, that you should understand. And the temperature will be 433 to 453 Kelvin, and it gives you cyclohexanol. So in all these reactions, what we are trying to understand, that arrow conditions are pretty important, and you should know what is the reactant, what is the product. The next one is reduction of phenols. In the reduction of phenols, phenols is reduced with zinc dust, and it gives you the formation of, yes, it will give you the formation of benzene. So here this is all about the chemical properties of alcohols and phenols. The key reactions we have discussed. What are the important reactants and important products that you need to revise for your exams, that you should understand here. Coming on to the next one is ethers, the last part of this topic, alcohols, phenols and ethers. In ethers, again the first important reaction is an important one, that is dehydration of alcohols. Dehydration, removal of water molecule. Again conditions are very important. What is that condition? 413 Kelvin. Now this is again something what you should understand, and this is very tricky as well. If you are taking 413 Kelvin, you will get ether, but if you are taking 443 Kelvin, it gives you alkene called as ethene. So both the reactions are very close, very confusing. So be alert. What I have said, alcohols will give you ethers when at 413 Kelvin. Alcohols will give you alkene when at 443 Kelvin. So both reactions are very close, very important. So this is the reaction wherein it is dehydration to give you ethoxyethane. The reaction here is formation of ethoxyethane. Now here this is the reaction basically wherein ethanol gets converted into ethene, but when the temperature is 443. Previously for ether the temperature was 413. The temperature change is what you students need to know when you're writing your exams. Moving on, the very known reaction, Williamson's synthesis reaction for the preparation of ethers. Now in this reaction, in this method, what exactly happens? Alkyl halide is treated with sodium alkoxide. Whenever any reactions you are studying, two things very important. You know the name of the reactants and you know the name of the product formed. That is something very interesting and very important. Same way, when I say Williamson synthesis, what do you understand? The first thing, yes, alkyl halide. Second important thing, sodium alkoxide. So two words that you need to pay attention on. Now here alkyl halide, this is alkyl halide here, and this is sodium alkoxide. So with this alkyl halide, this is Rx and this is sodium alkoxide. Now X from here and Na from here. See that key things, X and Na will give you NaX. And what are you left out with? Yes, ROR, and that gives you the formation of ethers. So this is how you remember for your exams, that X and Na removed, NaX is out. And this is something very important as well as far as your exams are concerned. Second thing, now there are some of the mechanisms coming in between, but right now for your 12th examinations, let us not much get worried about it. We need to only concentrate on the reaction part. Alright, separately we can discuss about mechanisms. Now here this is sodium tert butoxide will react with methyl bromide. Again the story remains the same, that Na has to combine with Br. Now that is going to give you NaBr, right? Na and Br giving you NaBr, and what you have the next product coming up is tert butyl methyl ether. So that's an important reaction for your exams. Yeah, now this was about the preparation of ethers. Coming on to the chemical properties, and before that you have this physical properties of ethers, ROH giving you here the hydrogen bonding. Now in the chemical properties of ethers, what are the important tests? The first test is reaction with sulfuric acid. So laboratory test for ethers. Ethers basically, yes, ethers are neutral compounds. That is something very important thing. Neutral compounds in aqueous medium. Generally they will not react with what? With bases, cold dilute acid, or reducing or oxidizing agents. So that is what you can call them as inert ethers. Why inert? Because they generally do not react with all these set of compounds that I have underlined already. However, ether dissolves in cold concentrated sulfuric acid and it forms dash salts. A question comes up. It forms dash salts. It is oxonium salts. So it will result into the formation of oxonium ion or oxonium salts. This property of ether distinguishes from the hydrocarbon. Reactions involving group of ethers. Now when I'm talking about the reactions involving group of ethers, the first one is formation of peroxide. Now again diethyl ether, when it combines with oxygen, it gives you peroxide. Now when I say peroxide, we should know where is the peroxide group coming up. This is O single bond O. This is called as the peroxide group. So ether will combine with atmospheric oxygen, and what does it forms? It forms peroxide. So all ethers which have been exposed to atmosphere, that is containing oxygen, will form peroxide. And this is an undesirable reaction. Why do I call it undesirable? Yes, because peroxides are hazardous and they are going to have a hazardous reaction, or they decompose violently at high temperature. So this is again a key word coming up, key points coming up that we might miss out if we don't read the textbook carefully. The next reaction involving CO bond. CO is carbon oxygen bond. Reaction with hot dilute sulfuric acid. What is that reaction also termed as? It is also termed as hydrolysis reaction. Ethers when heated with dilute sulfuric acid, they will undergo hydrolysis, and what does it gives? It gives you either alcohols or phenols. So you can get again a question like this: what happens when ether undergoes hydrolysis? It gives you the formation of alcohols, or it can give you the formation of phenols. Yeah, some of the key reactions are mentioned here. ROR plus HOH. Now this will give you twice ROH. But if it is ROR dash, then it gives you ROH and R dash OH. Alright, the next one, that is distinguishing test for alcohols. Now we are going to talk about how will you distinguish alcohols, the types of alcohols. Yes, primary, secondary and tertiary alcohols. So primary, secondary and tertiary alcohols, they can be distinguished from each other by something called as Lucas reagent. So here the reaction is ROH, which will react with HCl and ZnCl2 and will give you RCl. Now basically, what is Lucas reagent? You can get again a question for what is Lucas reagent. So let's try to understand what is basically Lucas reagent, or how will you answer the question for what is Lucas reagent. So a concentrated HCl and ZnCl2. That mixture of concentrated HCl and ZnCl2 is called as Lucas reagent. Now alcohols are soluble in Lucas reagent, but the product alkyl chloride is not. That one thing you have to remember. Second important thing is what happens to primary alcohols when it is reacting. So primary alcohols will turn the reagent turbid only on heating. So that turbidity is only after heating will be for primary alcohols. Now compare this with tertiary alcohols. They will react faster and the turbidity will be instantaneous. So that turbidity also will come, you will come to know what type of alcohol it is. If for example, if it is, I am talking about an alcohol where the turbidity is formed instantaneously, then which alcohol am I talking about? Yes, it is tertiary alcohol. If I am talking about where the reagent is forming turbidity but takes some time, then it is going to be secondary. And if the turbidity is formed only after strong heating, then it is going to be primary. So this is how you can decide whether which of the alcohols we are talking about. The next one is reaction due to breaking of OH bond. Now the reaction due to breaking of OH bond, that is first one that we have discussed already, that is wherein you will talk about ROH plus water. Now if OH bond breaks, this OH bond, if this bond breaks, this is going to give you H3O plus. This is what is H3O plus. So that gives you the formation of hydronium ion. So that is the formation of hydronium ion taking place. The next one is talking about the next group, that is the next reaction is acetyl derivative group reaction. And what is that acetyl derivative group reaction? It is alcohols reacting with acid chloride. So reaction of alcohol with acid chloride also gives you the formation of ester. So ester formation reactions, alcohol plus acid chloride gives the formation of ester. Phenols react with acid chloride, gives you ester. This is another set of important reactions. So you have to remember where ester formation takes place. The next reaction is reaction involving breaking of CO bond. Previously it was breaking of OH bond. Now it is breaking of CO bond. Now here it is HI greater than HBr greater than HCl. Now for the reactions involving breaking of CO bond, it is the reaction with hydrogen halides, HX, wherein you have HI greater than HBr greater than HCl. Now for HCl reacts only in presence of anhydrous ZnCl2. That one point is again that you need to remember as far as your exams are concerned. The next reaction is reaction with phosphorus halide and dehydration of alcohols. Now for reaction with phosphorus halide, it's the same reaction that we have done in halogen derivatives. Now in case of halogen derivatives, we have done wherein alcohol reacts with phosphorus trihalides or phosphorus pentahalides. And what does it gives you? Yes, it gives you the formation of alkyl halides. So reaction with phosphorus halides will give you the formation of, either you can say it gives you phosphorus trihalide or pentahalide giving you alkyl halides. The next reaction is the reaction that is dehydration of alcohols to alkenes. Now here dehydration of alcohols to alkenes is removal of water molecule, and the rule that it follows again is a important one, Sedgwick's rule. Right now for 12th it's not much more into consideration, but for your competitive exams, yes, you need to know these rules. These rules are very important there as well. Now coming on to the reactions of phenols. Now in the reactions of phenols, what are the important reactions of phenols? In the reactions of phenols, phenols undergoes electrophilic substitution reactions more readily as compared to benzene. Now the first reaction, the important one which are asked generally in the board exams, halogenation of phenols. Now if it is bromine water, then the product that you need to remember, it is 2,4,6 tribromophenol. So if it is reacting with bromine water, what we will get the product? Yes, it is 2,4,6 tribromophenol. Second reaction is bromine liquid. Now when I say bromine liquid, it is organic solvent. So here it is bromine liquid. What is the organic solvent? CS2, carbon disulfide. Here you will not get 2,4,6. Here what is the product? Yes, you remember this, orthobromophenol, parabromophenol. So you will get here the formation of orthobromophenol and parabromophenol. Moving on to the next one, that is nitration reaction. Now in case of nitration reaction, again this is something very, very important. This is the only reaction in your textbook where you have got the products together coming up in different formats. Otherwise you get confused with the formations. I'll tell you how. Now here this is going to give you orthonitrophenol, and this orthonitrophenol is the major product. Generally we say para compounds are major product, but here ortho is major because of intramolecular hydrogen bonding. That is the reason why this is going to be a major product. The next one is the reaction with concentrated nitric acid. Now previously when I am talking about the nitration, it was dilute nitric acid. So here this is dilute nitric acid. Now here it will be concentrated nitric acid. And this together, yes, a new word, concentrated nitric acid and concentrated sulfuric acid together. What is that called as? It is called as nitrating mixture. So when phenol reacts with nitrating mixture, it gives you the formation of picric acid. So it will give you the formation of picric acid. So when phenol reacts with concentrated nitric acid and concentrated sulfuric acid, a very important compound and a board question, picric acid is obtained. That is 2,4,6 trinitrophenol. The another name is 2,4,6 trinitrophenol. The next reaction, sulfonation of phenols. Now again for sulfonation of phenols, you have got the sulfonation reaction with sulfuric acid. Two conditions coming up. What is that two condition? One is at ordinary room temperature, and the second reaction is where you are using concentrated sulfuric acid at 373 Kelvin. So when you are using the reaction for 373 Kelvin, that is something very important. That time you get a para derivative. How to remember? Higher temperature, para derivative, lower temperature, ortho derivative. So this is how you will get the two compounds. The next one, the next reaction, a very important question and a name reaction coming up, Raymer-Tiemann reaction. What is that Raymer-Tiemann reaction? Phenol on reaction with chloroform and aqueous NaOH. In the first step, it gives you intermediate. That intermediate again will give you the next intermediate in the second step, and finally, yes, and finally what you get is the salicyl aldehyde. So you should know the steps coming up. Phenol, first step giving you the first intermediate, then it gives you the second intermediate, and finally it gives you salicyl aldehyde formation. So this is how phenol gives you the formation of salicyl aldehyde. Kolb's reaction. Now there was salicyl aldehyde. Now this will be salicylic acid. Now for Kolb's reaction, here phenol reacts with carbon dioxide. There it was chloroform and NaOH. That's what I told you previously. Try to recollect, remember, note the reactants and the products so formed. So what happens in that case? In the first case, as I mentioned, first case what are we doing? That is here sodium phenoxide in the first step reacts with carbon dioxide. What will it give you? Yes, it will give you sodium salicylate. And in the next step, it undergoes acid hydrolysis or hydrolysis to give you the formation of salicylic acid. So this is the formation of salicylic acid taking place. physical properties, and before that, that was the Williamson synthesis reaction. Now, in case of Williamson synthesis reaction, as we mentioned, that it gives you the formation of corresponding ethers. So that was the reaction for preparation of ethers. Next is physical states and boiling point. Now, in the physical state of ether and boiling point of ether. What is that physical state and boiling point of ether? Dimethyl ether and ethyl methyl ether are gases. So lower are gases. Then you have got liquids. They are inflammable in nature. See the words: inflammable, gases, liquids. And a very common thing, as the molar mass increases, boiling point increases. So 4 points are ready for your answer. This is how you remember your points. Polarity and solubility. So compounds are polar and they are soluble. Yes, if you have a polar compounds, they are soluble. If you have a non-polar compounds, they will be comparatively insoluble in nature. Continuing with the chemical properties of ethers. Yes, the reaction involving, the reaction we are talking about, the reactions involving CO bond. Now for ethers, as I mentioned, it is ROR. So this is the CO bond. This is the bond we are discussing. So reactions with hot dilute sulfuric acid. Ethers, when heated with dilute sulfuric acid, undergoes hydrolysis to give either alcohols, or it can give you the formation of phenols. Now in the reaction for ROR, now this ROR, when I am talking about, that ROR is basically a symmetrical ether, and the second one, that is ROR dash, that ROR dash is unsymmetrical ether. This is unsymmetrical, this is symmetrical. Now if you have a symmetrical ether, you will get 2 molecules of alcohol. So here this is 2 molecules, twice ROH of alcohols that you have. So this is the 2 molecules of alcohols. If you are having unsymmetrical ether, then you will get 2 different molecules of alcohol. So that's a very important point. The next reaction for ethers is reaction with PCl5. Now for the reaction with PCl5, ROR dash with PCl5, when it reacts, this will give you the formation of RCl, that is one alkyl chloride, R dash Cl, the another alkyl chloride, because it's a unsymmetrical ether, ROR dash. Had it been ROR, then you will get 2 molecules of RCl. That is something very, very important for your understanding. The next reaction, reaction with hot concentrated acid. Now reaction with hot concentrated acid, like say HX, here you have the reaction with HX. This is the reaction with HX. When it is reacting with HX, ROR plus HX will give you RX in the first step, and in the second step, then it gives you ROH. So you will get a mixture of 2 different alcohols, the 2 different compounds rather, alkyl halides and alcohols. So you will get 2 different compounds, and the very important question that generally comes in your objectives is the order of reactivity. What is that order of reactivity? HI greater than HBr greater than HCl. So this is something what you need to remember for your exams, as far as the exams are concerned, the points are concerned. Coming on to some of the last ending portion of this topic, that is alkyl aryl ethers. Now what is alkyl aryl ethers? Let's try to understand this first. What is alkyl aryl ether? Now this is a benzene ring and this is a methyl group, and in between you have oxygen. That is alkyl aryl ether. They have strong and they are shorter bonds, and that when they have strong shorter bonds, that reaction is not that easily possible. When it reacts with HI at a higher temperature, what is that higher temperature? Pre-98 Kelvin, it gives you phenol and methyl iodide. So this is the reaction when it gives you formation of the phenol and methyl iodide group gets formed. The last chemical reaction is electrophilic substitution reaction. Now in case of electrophilic substitution reaction, the first thing, where will the reaction take place? At what position? Yes, electrophiles, positive charge. Where should they attach? Ortho position, para position, ortho position. This is how you simply understand. Ortho and para position, the substitution has to take place. Which are those reactions? The first one is halogenation reaction. Now in case of halogenation, when you start with anisole, it will give you the formation of bromoanisole, ortho and para. Friedel-Crafts will give you the formation with AlCl3, and with that AlCl3, it gives you 2 different compounds as 4-methoxyacetophenone, and the another one is 2-methoxyacetophenone, again a name reaction. Nitration reaction will give you 4-nitroanisole and 2-nitroanisole. So these are the 3 important chemical reactions. And ending the chapter, the last part, 1 or 2 marks question, generally asked, uses of alcohol, phenols and ethers. So generally you can just have a quick look on the topic. Methyl alcohol is used as solvent for paints and varnish. Second one, antifreeze agent, automobile radiators. For ethers, yes, previously it was for anesthetic, nowadays it is not used. Diethyl ether is used as solvent for Grignard's reagent, waxes, oil, etc. And lastly to talk about is about the phenols. Now in case of phenols, it is used in the preparation of phenol formaldehyde resin, bakelite. Again, this is 1 mark question. Phenols are used as an antiseptic and they are also used in common products like air fresheners, deodorants, mouthwash, calamine lotion, floor cleaners. So the last part wherein you can talk about the uses of alcohol, phenols and ethers. So this is all about the topic, a quick revision of alcohol, phenols and ethers. Hope you will understand, learn more better in this way. And students, for further such videos, please be tuned with Study Live. Thank you.